Hello and welcome to this tutorial video in which we will show how to use an online software application to plot a histogram on a graph paper. Some of the main features of this application are the following. First, we determine the class boundaries of each class. This will define where each bar of the histogram starts and ends. Hence, you will have total control on the width and position of each bar. Secondly, the scaling for the x-axis and the y-axis of the histogram can be adjusted. This will determine the width and the height of the plot. One can also customize the labels, that is, add a customized x-axis label, y-axis label, and also a title for the histogram. It is also possible to add a frequency polygon over the histogram. One can also change the color of the grid, the color of the histogram bars, and also the color of the frequency polygon. Finally, the histogram is available for download directly to your device as a PNG file. This application outputs a plot that could be useful in the academic sector. For example, teachers can add such plots to their class notes and students can find them useful for their statistical assignments and projects. So let's start off by accessing the application. We go to the website datasciencegenie.com. Then we scroll down and search for the tool, the application related to the histogram. The exact link will be given in the description below the video. As you can see here, on the left we have the input for the plot, and on the right you have the output, which is mainly a table with the frequency table together with other descriptive statistics, a preview of the plot, and also a download button. Let's consider two different examples. Here we have the first one. We have the frequency table of length. We have the 6 classes together with the frequency. In this example, we notice that the classes have equal widths. For example, the first class has a width of 10, 30 minus 20, and the same for the remaining classes. Note also that the upper boundary of a class, the upper limit, 30, of this class, is equal to the lower limit of the next class, 30 here. This would ensure that the bars of the histogram are adjacent to each other, they are touching. So let us insert this frequency table into the application. Okay, as you can see, the output would update automatically. We have the frequency table here together with the class width. The class widths are all equal to 10 in this example. We have also the class mark. The class mark is the midpoint of the lower and upper boundary, and this will be used by the application in order to plot later on the frequency polygon. The application makes also an adjustment to the frequencies and it obtains the estimated frequencies. However, in this example, since the class widths are all equal, the estimated frequencies are the same as the frequencies. And the histogram would then plot the estimated frequencies. Next, the next input is the standard width. In this example, since all the widths are equal, we set it to be equal to the width of the classes, which is 10. The x-axis scaling, we will make it 5 units per centimeter, and y-axis scaling 50 units per centimeter. Okay, so this means, for example, let's take the x-axis. 1 centimeter is made up of 5 small boxes. So 1 centimeter here would represent 5 units, so from 20 to 25. Obviously this could be adjusted. For example, let's make it 10. In this case, the width becomes half of the previous width. So 1 centimeter now would represent 10 units. If we make it, for example, 2.5, we have 1 centimeter would represent 2.5 units. Same thing for the y-axis. If we make this equal to 25, we have 1 centimeter representing 25 units. Then we can change the labels of the plot. For example, the title, let's make it histogram of lengths. The x-axis label, we make it length. And we leave the y-axis label estimated frequency. We can tick the frequency polygon, and you can see the frequency polygon is added to the plot. Finally, we can change the colors of our plot. For example, let's make the grid color blue, the bar colors orange, and the frequency polygon, let's say purple. Okay. If you're happy with the plot, you can download it as a PNG file. And it's downloaded to your computer. Let's consider a second example. So here we have another frequency table. Let's say a frequency table of diameter. In this case, the classes are not all equal. Let's copy this frequency table into the input of the application. We can refresh the page. Okay, again we see that the output is updated automatically. In this case, the class widths are not all equal. So the standard width, let's make it 1. Okay, it could be any of these 3 different class widths. And now the application made an adjustment for the estimated frequencies. So from the frequencies, it obtains the estimated frequencies using this equation here. Next, we change the scaling for the x-axis and the y-axis. Let's make them 0.5 and 0.5. If you're happy with the scaling, you could move on to the labels. Let's say x-axis in this case is diameter. So the plot title would be histogram of diameter values. Again, we can add the frequency polygon and also change the colors. Let's say gray, purple. Let's leave it orange. Let's see. If you're happy with the plot, again, you can download it and it's available on your device. Thanks for watching the video and hope you find it useful. And please take a moment to like this video and subscribe to the channel in order to keep updated with new video posts.